Okay, we've had two open systems. Now we're going to do a closed system. And really the big difference there is an external demand. This right side, instead of being 0, is now going to be some number there. But the rest of it is really the same. Now we can also take this sort of a step further. We can say that if we take the inverse of this and multiply that by that I minus T matrix, and if we do that on the left, times that demand matrix, these will cancel. They really become the identity. And you just get X is this I minus T inverse times D. So we can go even a step further with these things if we want to. Let's have something that we can talk about. That farmer and builder and tailor situation. If you remember that, farmer, builder, tailor, produce. And then the user, farmer, builder, tailor. We had a 3x3 matrix. This, we're going to change some numbers there, I guess, for whatever reason. 0.25, 0.15, 0.10, 0.27, 0.05, and 0.09, and 0.08, 0.17, and 0.04. I guess the other numbers were too nice. That is our T matrix, the input-output matrix. We're also going to, for our farmer, builder, and tailor, have the D matrix. This is the demand. We'll say this needs 50, and this 65, and this 85. That's the demand outside of the system. And of course, X is the X1, X2, X3. So if we work this one out, we need the X of 1, X of 2, X of 3 equal to the I minus T inverse times the D. Well, we're going to put those in and use our calculator to do this stuff. If we grab the calculator once again, now we're going to run this program, the input-output matrix. There are 3 industries, and we're going across the row, remember. 0.25, 0.27, 0.08, 0.15, 0.05, 0.17. 0.1, you could say 10. Oh man, I made a mistake. Can I go up? No. Let me get out of this and start over. Make sure you put it in correctly, or it's not going to be the right answers, of course. So, 0.25, 0.27, 0.08, 0.15, 0.05, 0.17. Got the point in there that time. 0.1, you can say 0.10, it doesn't care though. 0.09 and 0.04. So there is the input-output matrix, the demand matrix. D1 is 50, D2 is 65, and D3 is 85. And now we can calculate this and get this stuff. Now, Now we calculated x before. It was a little bit different, and it gave us, because it was the closed system. This is now an open system. I put closed up there again. This is an open system, and it now gives me these numbers. So x of 1 is 116.88, 106.69, 110.72, and they've rounded that, because these are whole things, whatever they might be, to 117, 107, and 111. These might be hours, these might be things that we can't break up. So it does that also for us and gives us those answers. So, in order to satisfy this external demand and the internal demand by these industries, we need to produce this much. Exit. Okay, let's make sure we understand how to answer some of the questions in the book. I just rewrote what we just figured out for the farmers, the builders, and the tailors. Remember, T is the technology or the input-output matrix. D is the external demand. So if they want the external demand, they really have to give that to you. This is what they want outside of the business. The total production is when we calculate that. That's really this X. That was that last answer, the total production of all that stuff. This will take care of the external demand and the internal demand. So what is the internal demand anyway? Well, this was the percentages we needed for each of these between each other, for the farmer, the builder, and the tailor. This is what we have to produce totally. So if we take that T and multiply by the P, that is the internal demand. Now if we look at our matrices, we can usually see from this, A is a 3 by 3 and B is a 3 by 1. I don't know which one's which here though. Let's look at the 3 by 3. That is the technology or input-output matrix. Let's get out of there. Go back in. Go over to edit. Let's look at the 3 by 1.